All right, so I'm going to talk about today about server discovery in the Fabric. It is a feature that is going to be integrated in the next release, 1.2. So the outline of this presentation: first, I'm going to present a demonstration of the feature. Afterwards, I'm going to do some recap of the transaction flow. For those that might see the recording and are new. Afterwards, I'm going to explain the rationale, the incentive or motivation for the service discovery feature. And afterwards, I'm going to delve into the high-level flow and design details, implementation details, and also how it complements other features in Fabric. And also, lastly, I'm going to explain about the current status of the development of the feature. So in the demo, what I'm going to show you, essentially, I have two organizations, org1 and org2, but I'm also going to use the standard end-to-end CLI, but with a slight twist. The endorsement policy is end of org1 MSP and org2 MSP. Meaning that in order for the transaction to be validated, it needs to collect endorsements from both organizations, one peer from each organization, org1 and org2. And let's say that this server here, the one with the globe, this is a peer, and it wants to collect endorsements for chain code myTC in channel myChannel. And he's asking himself which peers should he contact in order to obtain endorsements such that the transaction so this is not a peer, this is a client application running on a server, and it needs to collect endorsements from peers such that when the transaction is going to be validated, it is not going to be invalidated because the endorsement policy did not match. Now, what it does, this client application, it performs a query to some peer. In the demo, it is going to be a peer in org1, and it is going to ask for some descriptor that having this descriptor, the client knows which peers to contact in order to get endorsements. So the peer, the service discovery on the peer is going to return to the client two things. First of all, we have something called layouts. What is layout? Layout is basically several options, such that each option details some sort of description that maps a certain type of principal group to count. So in our example, we have two organizations. So the output that is going to be returned will have G0, G1. It is done in such a way because the name of the group in the layout is generated automatically. It's not a problem for now, and we need only one endorsement from each organization. Next, we have something called endorsers by groups. Using this map, the client is going to select from each group a number of peers corresponding to the quantity that is described in the quantities by group. Now, in the demo itself, I have a web server, and this web server is going to describe something that shows all combinations of obtaining an endorsement for the transaction. So here we have the important function of the code. Here we see that we create a new service discovery request. We say this request is associated with the given channel, and we say that this request asks the peer for endorsers for chain code for this given chain code. Now, we send this request to the peer, and afterwards, what we receive back is some descriptor, and this descriptor is the same descriptor from a previous slide. And what we tell the client, we ask the service discovery client inside the SDK. We ask it to give us all options of all endorsements. Next, what we have here is just we show how we print it nicely to the web UI. And lastly, I want to show that the current client implementation in Go, we have a reference implementation of the feature. We have right now 3 API calls: config, which returns the configuration of the channel. For example, ordering service endpoints, MSPs, MSP configs. Also, we have peers, a query that returns all of the peers in the channel. And lastly, we have the endorsers, which is it returns some randomly chosen group of endorsers or of endorsing peers, such that this group, if we collect endorsements from all of these peers in this group, then the endorsement policy is satisfied. Okay. So. I think that can everyone please mute? Okay. So I'm going to start now the demo. I'm going to spin up the environment, the regular end-to-end, as I said, just with a slight twist that the endorsement policy is an and between 2 organizations. Now we join all peers of the channel. Update Yacov peers. And of course, we also instantiate the chain code on some of the peers. In contrast to the regular end-to-end, I have the install function running on all of the peers, not one. So now I'm going to connect to the CLI container. And I have here a binary which I created, which this binary runs the web server. I'm going to tell the web server to connect to peer 0 or 1, example.com 7051, and to ask about chain code mycc and channel my channel. All right. And now I'm going to open web application. And we see here that so what we see here, the web server has inside of it a service discovery client, and it queried the service discovery service on peer 0.org1 example.com for a descriptor, and it analyzed the descriptor and obtained all the possibilities to get endorsement. So here we see, first of all, the options. We have overall 4 options, right? Because we have 2 peers in each organization. And we see that in every option, we need endorsements from both organizations, but from some peers. Now, from this query, we also get additional data, such as the organization the peer belongs to, the peer certificate, and also another important thing is the height of the ledger in the peer. Now, if we refresh this, we will see that the queries are the queries that are second, third, and so on and so forth they took much less time than the first query. The first query took 14 milliseconds, but afterwards it gets much faster. And this is because we have all kinds of caching layers that we optimize the speed, and actually we can do it such that this is a very lightweight service. The peer, assuming the caches are hit, the peer almost doesn't do any hard computations such as, well, maybe besides the TLS handshake itself. Okay, so that's for the demo. Now back to the slide. But any questions so far?
Oh, sorry.
Yeah, I have
Just one quick
question. Yeah, it seems like from this that the clients will now, like the Fabric SDK clients, in the past we've only needed a gRPC protocol for everything. It looks like this is using a HTTP. Is that correct?
No, it is not using HTTP. Just in the demo, I just use a web application because it looks nice. But the service discovery itself is not an HTTP. It's a regular gRPC, like all of Fabric services. Well, except for Fabric from Fabric CA, right?
Right. Okay. The only other question I have is, there seems like there's two things here. There's the discovery of the network, okay, and then there's also on top of that is the endorsement that might be required for specific chain code. Is that right?
Yeah. So these two things that you mentioned, plus the configuration of the channel, because
right. Okay.
Think of
those are entirely separate, right? I mean, from an API perspective.
It is a different query, if that's what you mean.
Right. Okay. Thanks.
All right. Any other questions?
Yeah, Yacov, this is Angelo. I joined later. Sorry for that. Probably you said already, but there is any access control? Who can query the discovery service?
Great question. So it depends on currently in the current implementation that we have so far, we only have channel queries, and to query service discovery, you need to be currently a channel reader.
Okay, very good. Okay, that was what I was expecting. Okay, thanks.
I have one more question.
That web page, web UI you were showing, I just wanted to clarify one thing there. For the demo.
While you're
quickly. Yeah, who is this, by the way?
Yacov, this is Manish. Can you go back to that web UI which you were showing as a result of query? I just wanted to clarify one thing there.
Do you see?
Yeah, right. So the ledger height which you print here is the height of the current ledger, or is it related to the configuration at which point that configuration took place?
No, it is the height of the ledger that the peer reported.
Basically the current latest height.
It is the ledger height of that the peer has.
Okay. Nothing to do with the configuration basically as such, right?
It is not a configuration. It is actually the number of blocks that the peer in the corresponding row has.
Yeah, got it. Because I was wondering probably that height also would be meaningful at which height that configuration took place.
Yeah, we can certainly add that. Yeah, I know why you're asking this, and yeah, we can add that too.
I just wanted to have a clarification that you already have it or not.
Yeah, yeah.
Thank you.
So what is the reason for showing the ledger height there?
So the reason would be explained in the next slide.
Okay.
I have a question too, because connection with TLS, are you providing them the client search for that?
So if we use TLS, if the peer uses TLS, then it is assumed that the client uses the TLS of the.
Okay.
All right. So next. So now after I showed you the demo, I'm going to take back lots of steps. I'm going to do a recap on the transaction flow and then follow the outline. So in the transaction flow, we have a client on the left side. The client wants to send a transaction such that the transaction will be validated. What it does, it sends a transaction proposal to a set of peers or one peer. That peer executes chain code, and number 3, the endorsements are signed by the peers, returned to the client. The client aggregates all of these endorsements, batches them into a transaction, submits the transaction to the ordering service. The ordering service orders the transaction into some block. Later on, the block is disseminated somehow either directly from the ordering service or from other peers to all of the peers. The peers in turn validate the transaction, and then if the transaction is validated, it is committed in the ledger. So currently, client applications use something called I think it's called a connection profile file. So in this connection profile file, it has many disadvantages. For instance, it has a static mapping of the peers and the orders, and also if you see here in the green part, you need to encode the client needs lots of configuration of all of the peers in the channels only to be able to work with the channel, and that's a very big disadvantage. Just think that if we have a channel that has like 5 different organizations, then in order to endorse on all of these 5 organizations, we need the TLS TA certificates in the client configuration on all organizations. Another problem that if a new organization is added to the network, so this connection profile file needs to be updated. Also, obviously, this is a file, right? The configuration here is static, so there is no failure detection of any kind, and actually, the only failure detection that is done is when the application actually tries to endorse and fails because it can't contact the peers or the order. So all of these, I think that this presents a lot of burden to the developer. For example, just think of the endorsement policy. The developer, it needs to have prior knowledge of the endorsement policy in order to write his own application. But that doesn't really make sense because if now a new organization is added to the channel, the developer, it might need to redeploy his application because the application is configured to collect endorsements only from now a subset of the organizations and not from all of them. Also, if the organization is removed from the channel, no one updates the application, so it is broken because it will try to collect endorsements from an organization that does not now exist in the channel. Now, someone asked why would we even want the ledger height? So let's assume that we have 4 peers, and one of the peers is behind. And the 3 first peers, they know that Bob's account balance is $150, but the last peer, it still thinks that the Bob's account balance is $500. So if an endorsement is being done against that peer 3, it is going to be invalidated by MBCC, and that's a computation time and also time that is wasted. So let's make an intermediate summary. The static configuration of the application, it is not adapted to network changes. Also, the application needs beforehand all of the root CA certificates as a prerequisite in order to participate in the channel. the channel reconfiguration, it breaks running of applications. And also, the application doesn't have any way of knowing which peers are the best candidates for endorsement. So if we had some service that would tell us all of that, what would be the of it, from it? First of all, we would want to be able to query dynamically and the queries to be grouped by the organizations, right? Because for every organization, you need to create the connection with a different TLS root CA certificates. Also, we would want the bootstrapping of such a client to be as thin as possible. Ideally, the client should only have a certificate only for a single organization that it trusts its peers. It contacts this organization, it contacts its peers, and receives from it all of the data that it needs. Also, the application logic, it should not even care about what is the endorsement policy of the chain code in a channel. It also should not be affected if the channel membership changes. And lastly, we will want the SDK to know what is the ledger height of the peers in order to know which peers it should select over others. Any questions until now?
Yes, this is Angelo again, Yacov. Just a sanity check. So the client asks it invokes the discovery service on the peer that it is trusting, right?
Yes. Yes.
Okay, that's the trust assumption. Because now I was thinking, okay, what if the discovery service is compromised? Then it can give back endpoints of malicious endorsers, and then it becomes a central central point of failure. But okay, that's the trust assumption.
Yeah, but Angelo, I think that we can always structure the application flow such that it would query multiple peers for their service discovery and compare the results, right?
Yeah, that's definitely an improvement. If you don't want to trust a specific peer, that's definitely an improvement. Yeah.
All right. So the high-level flow, basically all of this feature, it looks like it is a local feature, right? We ask a peer, and the peer gives us its information. But actually, a big part of the operation is actually being done in the background in a distributed way via gossip. So even now, peers, when they share with other peers that they are in a certain channel, they share all kinds of information that is useful for them. For example, their identities, their endpoints, and their heights. So the idea is we can just use that information and that mechanism that disseminates this peer channel metadata among the peers of the channel, and we also disseminate on that the chain codes that the peers have installed, which are also instantiated on that channel. And also the peers, since they have the endorsement policies in their ledger, they can compute all of the descriptors that I showed you before. They can compute that, and they can tell the client these results. So assuming we have some peer here, basically it sends a message saying that this is my endpoint. I have a chain code called asset chain code on the channel trades, and my ledger height is 42. And then when the SDK, it asks some other peer, who should I contact for a asset chain code on channel trades, that peer can return an answer that, well, you should query peer2.contoso.com, etc., that is in the organization Contoso, because it sent a message via gossip. All right. I will make a pause here for to collect some more questions. Great. Yeah. Any questions?
So Yacov, just one high-level question. So, I mean, in practice, are you thinking that it will be used on, like you will enable on some of the peers in the organization, because too much redundant information otherwise would be stored on multiple peers, right? And pooling of information which might not be required and which grows with the size of the network or those kind of things.
Can you repeat what you asked? I didn't really understand.
Okay, so to take a step back, so what I was wondering is, so in theory, for example, this information can stay outside the peer as such because it has nothing to do with peer per se, right? It's for the client to answer few of the queries that from where to start transaction flow and so on. But I think since you have this within peer, so potentially within all in an organization, there should be some balance that you wouldn't want all the peers to have this information replicated and kind of putting the extra load which grows with the size of the network as such.
Oh, so actually all of this information that is disseminated, this is not the scope of this presentation, but we actually have boundaries. For example, you may configure certain peers to be invisible to other organizations. So if you query a peer for server discovery, even right now, these peers will not be returned in the query result. Okay?
And
so
this also, and those peers will not maintain this information about other visible peer of the organizations?
So they maintain that information about their own organization only. Basically, in one organization, every peer knows about the other peers, right? But also, I also want to say that this discovery service as a feature, it is toggleable in the configuration. So you can just configure the peer not to participate in server discovery.
Okay.
All right, let's move on.
So
I'm going to talk. Yes.
On these, there's also, like you said, there's things like we get the chain height to figure out, what are the best candidates to probably do an endorsement on.
Yes.
Is that something that the client has to do, or is that something where we say, here, we want to invoke this chain code, and you come back and say, okay, here's the peers that you should probably get the endorsement on?
So the answer to this question is actually sort of unknown, because all client implementations are now either not started yet or work in progress. But I think that it would make sense. I think it would make sense to be to have maybe some sort of a declarative API that would say, collect me endorsements, but prefer peers with a better ledger height, etc., etc.
Okay, so this isn't really done yet, right? I mean, there's even design issues going on with this yet.
Well, these are designs of client API.
Okay, I'm still confused because I should say, I want to invoke this chain code. Now, do I get back just a bunch of metadata that I then have to calculate as a client and say, okay, I think this is the best two? Or do I just get back an API that says, oh, here, use these two peers to do your endorsement on? Where is the burden?
So I think that we could do either ways. Who is this, by the way?
Okay, it doesn't sound to me like that's been settled. The other thing is, like on channels, there's,
May I ask who is this, by the way?
This is Rick. I work on Java SDK.
Yeah.
The long lost cousin of the Node SDK. But anyhow, also there was a question I have on, when we configure a channel, I'm not sure if it was in that network configuration, but we also have like types of, this only addressed endorsements. Like we have things like, where, you want to invoke a chain code by just doing a query, not where you're doing an endorsement, or you want to do a query we have like 3 or 4 different aspects. Also, like whether or not a peer will be an inventing peer. Okay, how we need to know that when we're going to turn around and start a channel up. Okay, so we know what users want to listen to for events. How is that fed into that?
Well, it doesn't, because all peers are by definition, so all committer peers, and all peers are committers, right? So unless they didn't join the channel, right? But all peers that are committing peers are by definition also eventing peers, because you can connect to the event service.
Right, but I might have 30 or so peers that are committing peers, but I'm only sending endorsements to a few subset of those, and probably those are the only ones I'm going to want as eventing peers. I can't be sitting around and listening on all peers and say, okay, every peer is going to be an inventing peer, right? I mean, I don't think that would scale.
Well, it will not, but I don't see how that is related to the server discovery. I mean,
I need to know what peers that I need to know to get know when transactions are completed, because that's part of the SDK cycle. We listen to blocks, and when the transaction is done, we tell the client, oh, your transaction is done, and that's part of initializing the channel for us.
I agree, but it doesn't have anything to do with which peers you ask endorsements from, right? Because you don't need to we can take this offline if you want, or in the last part where I have a slide in which I'm waiting for questions. All right.
Hey Rick, it's Troy here. So in the Go SDK, how we're handling this right now with discovery, we have a default mechanism which will automatically select endorsement, and the user of the SDK can install a custom filter if they want to customize how to select which peers to use. On the other question about dealing with the static configuration, right now we're using regular expression matchers so that we don't have to specify for each peer whether it's a endorser or query or these kind of things. Instead, you can do this by, for example, domain name, or by any other kind of regular expression.
But that, to me, defeats the purpose of, if I have to know beforehand what peers they're going to be, that to define a filter for this, that defeats the purpose of the discovery aspect.
No, so you don't have to, right? So we did it so that we have the same default, so it'll automatically be selected for the user. They don't have to specify any peers, so we grab the information from discovery and automatically do this for the user of the SDK. If they have something more advanced, like you're talking about other scenarios, they can install a custom filter instead.
All right. So I would like to go on in the presentation. So I'm going to talk about now briefly about endorsement policies. So recall, what is an endorsement policy? It has 2 components. It has principles and something called threshold gates. So principles are basically properties that the identity is satisfied. For example, if an identity is a member of an organization org0, then it is a principal. An identity might be also an admin of that organization. Also, we have threshold gate, as I said. A threshold gate is just a binary operator over 2 subsets of other threshold gates, and of course, each such gate might be just instead a principal itself. So for example, if we have an AND on org1 member and org2 member, it means that this endorsement policy is satisfied only if we have a signature from org1 and a signature from org2. Now, as we know, the clients currently, they don't have MSPs, right? Only the peers have MSPs and orders have MSPs. So the clients can't really know if a given identity, if it satisfies the principle without having all of the MSP code, which is by now pretty complex. Also, even if you have the code, you also need to prime you need to prime the MSP instance with the configuration, etc. So the service discovery is going to do an analysis of the endorsement policy, and from this analysis, it is going to build that descriptor that I showed you before that is given to the client. So what is the input? We have a set of peers, identities of peers, and an endorsement policy. What we need, our objective is to find a minimal set, to find minimal sets of peers, such that every set, if the client asks for endorsements from every such set, then the endorsement policy is fulfilled. So what is the solution? It is represented as a tree. As we know, the endorsement policies they are represented in Fabric as tree, and we have here basically every threshold gate is translated to something called an out of. So for example, we have here at the root a 2 out of, it's a 2 descendants, and the leaves of this tree is the principles. So signed by 2 and signed by 3 means signed by org 2 or signed by org 3. So we take this tree, and what we do is we create a bipartite graph such that its right side is the identities of the peers, and its left side is the principles. Then we create a vertex between the principles and the peers if the peer satisfies the principle. So you see here, for example, that if peer 0 is in org 1, then we have an edge. Did I say vertex? An edge between them. Now, the output is the combinations that we can produce from this graph. But as we saw before, the combinations are not actually transferred to the client as the combinations themselves, because it can be a very large set. We create a descriptor that from that descriptor we can actually generate a random combination, because actually what the client really wants is a random combination. Since we don't have much time, I'm not going to talk a lot about this slide, but basically the naive algorithm from the previous slide, it doesn't work in cases where we have a peer that it satisfies 2 types of principles. Right now in Fabric, this is not the case, meaning there is no real actual sensible use case for that, because peers come from different organizations. But possibly in the future, peers can satisfy several principles, and then we need a more complex algorithm that will find the matching between the peers and the principles. There is such an algorithm called a hop-crop-carp. It runs in a polynomial time, which is good because it means that we can compute it relatively efficiently. If there will be a need, it will be implemented. Now I'm going to talk about the implementation details. So, as I said, the discovery service is the gRPC service. You communicate with gRPC, and what the client sends to the service is a request, and that request is signed. So it has the following structure. It has the request itself, the signature, and everything is wrapped in something called a signed request. Also, we have authentication info, the client identity, and the hash of the client TLS certificate. Now, the actual important part, which we need to focus on, is the queries part. So that's the main difference between this gRPC interface and, for example, the Fabric system chain code. So we can have all of the queries that the client needs in one single service discovery request. What we do is we simply put all of the queries that the client needs into this queries slice, and then the peer evaluates all of the queries and returns answers, either an answer or something like access denied if the client is not eligible of knowing the answer, in the same order in which the client sent. Now, each such query currently, it can be one of the three types. It can be a query for configuration. Configuration meaning to obtain the endpoints of the ordering service or to obtain the MSP configuration of a channel. We need that in order to know the root CA certificates and the root TLS CA certificates of the channel to connect to the peers and to the ordering service. The second type of query is the peer membership query, where we basically ask who are the peers in the channel, what is the information about them, such as ledger height, etc. And the last type of query, the one that I demonstrated today, is the chain code query, that we ask for a set of endorsing peers for a given chain code on a channel. Now, we are going to add soon something that is, I call it a non-channel scope queries. This will be useful, for example, if a client is some sort of monitoring application, or if a client is an operator and he wants to join its peers to the channel, but it needs to know the peers in the first place, so it can query service discovery for that also. Yes, and also I would like to talk about how this feature, I think one of the nice things in this feature is that it augments other public features. For example, we have a feature that it is experimental in 1.1, and it will be non-experimental in 1.2, which is called TiDB. To those of you that don't know, essentially what this feature means is that we send only hashes into the ordering service, and the public blocks only have the hashes of the original sets of the transactions, and we actually disseminate the pre-images between the peers according to some policy. So service discovery is also very useful for this feature. Why? Because if a client wants to send an endorsement to a collection, it would also need to know the configuration of the collection in order to not to send the data to peers that they're not eligible. Also, if the collection membership changes, the client can use their discovery to know about that. The next thing is we have a feature called ownable state in the future. The ownable state feature means that the validation policy for some asset transfer is based on who are the current owners of the asset. So if we have a client, and that client it wants to collect endorsements in order to transfer that state to someone else, or for example to acquire some state, it needs to know who are the organizations that this state belongs to right now. So it could use service discovery to do that. And the current status of this feature. So we have.
Yacov. Sorry if I interrupt. Just to on this slide. Just a few clarification that ownable state, the name will change to better reflect the functionality, because it does not necessarily represent the ownership of the asset, but it's more on the endorsement thing. So still, it might be that the owner of this state it's Alice, but she needs the endorsement of multiple peers. But so the concepts are separated. That's I just wanted to clarify this point.
Yeah,
but
sure.
The rest is fine.
I just wanted to simplify everything. Yeah, I just wanted to simplify it for the how to say.
Yeah, just to say that then ownable state will change. The name will change. It will be better clear for the community what is really what this thinks is really. Thanks anyway.
Okay, sure. So the current status of this feature is that the server side on the peer is mostly done. We are missing the channel membership queries and the collection support. We would add that. On the client side, there is some very, very good progress in the Go SDK part. And the Java and the Node.js SDKs, they are to be added soon. We need to talk about that and to synchronize. Also, I understand that there is some work going on to allow the peer CLI to collect multiple endorsements. This could also be very this can also use self-discovery in order to know what is the endorsement policy in the first place. We need to add documentation and interrogation tests, but these are pending the client-side implementation. Any more questions?
Does this also work with the ID mix?
What?
Is it for ID mix stuff with the new SMMSPs for that? Does it work with that?
So for the ID mix, I guess the answer is it depends, because I understand that there are various types of ID mix. For example, we can use ID mix to actually hide, right? We can use ID mix to hide the organization association of the peer or of the peers, right? So obviously you can't use self-discovery for that because you're not supposed to know from which organization the peer is. So we need to work on that part, but I think the way to do that is basically that if you have a custom validation plugin, what I hope to do is that the plugin could convey to the service discovery based on what you want to endorse. Based on that, it would say or not say, if it can't, which organizations you want to collect endorsements from. But yeah, that's a very valid question.
Something else that back on when you're selecting like peers to do endorsements on, I always thought I'm not saying that this is the only way to do some kind of redundancy, but sometimes when you just want one of a particular group, to actually get endorsements from multiple groups, multiple peers in that group. So if one of them, doesn't get connected or contacted, that you still can get a valid endorsement from that. Any way to how that works with this?
Okay. So we can divide the answer to a question into two parts. Either the peer is unreachable because it is dead and it is unreachable for a long time. In that case, the gossip protocol would identify that, and when you do another service discovery query, you would receive a response that would not have this peer in any of the views. Now the second part is if the peer died or is disconnected, let's say maybe 1 second before you try to endorse. Obviously there's nothing to protect against that, but for these cases, what you would do is you would ask you would hopefully have some logic in the application, either in the SDK or in the application itself, that would ask the service discovery descriptor for give me another set of peers, right?
Yeah, that's more overhead though. So also this using this mechanism, it seems like for executing any chain code endorsements, we have this one extra overhead of whatever this is to calculate this thing, right?
Well, but this is not a big overhead because it's not like you do crypto to calculate that. It is simply a simple graph matching.
But I know in a redundant of these because if I'm only dependent on that one for these endorsements, that would seem like to me a point of failure. I would have to have like a list of these, right?
Well, so the idea long term will be that when the application boots up, it could potentially query either one or a few let's call them bootstrap peers, and after you obtain the full membership of all of your organization or of some organization that you trust, there is no one prevents you to reusing service discovery to afterwards query them, right? So it's not really a single point of failure. Also, if we compare that to what we have now, which is static configuration, you have to agree with me that it is much better, right?
Well, I'm not saying that this is worse, of course. I'm just saying that there are some other aspects of this. Like I'm saying, the single point of failure. I see that I need a list of these to actually query. If I can't get to one, I need to be able to get to another one and say, because otherwise I can't use this to figure out my endorsements for executing to the chain code.
Right. So hopefully after when you boot up your application, after you get after you do one query, you can query for peers, and then you use that list to query recursively until you find out all of the peers in your organization, and then you don't have a single point of failure anymore, right?
Okay, but to do that, I have to do the bootstrap. Will I be told which ones are preferable to do these queries to? Which peers are my best to do these queries to?
So, Rick, how to say this?
Okay.
I think we can talk about that, but these questions are more relevant to the design of the SDK and not really to the service discovery, the discovery service design itself. I mean, we can talk here, in the call.
No, I mean, I got a bunch of peers in an organization. I think some of those are probably more primed to do these particular queries for the correct endorsement policies than some other ones would be.
Right, that is correct. For example, those that have a higher ledger height are ones that you would want to prefer over others, right?
But that's just a point in time.
Time?
That's a statement in time. 2 seconds later.
A statement in time, yeah.
Okay.
Yeah. Okay, any other questions? All right, so that's all.
Okay, thanks, Yacov.
Sure.